All right, in this lesson, we are doing an extension of factoring, which includes dividing polynomials. So to start our warm-up, we are just going to review factoring. And so this first example is a GCF example. We can divide each of these three terms by a GCF, a greatest common factor. Just looking at the numbers, 3, 6, and 12, 3 would divide each of these numbers. And then looking at our variables, we have x to the fourth, x third, and x. So x is the most we can divide each of these three terms by. And so we write the 3x outside the parentheses, and then we need to leave room to write our three terms after the division. And so 12x to the fourth divided by 3, you're dividing coefficients, subtracting exponents. So that would be 4x to the third, 2x squared, and then just a 1. 3x divided by 3x leaves us with 1, not 0. So make sure you have 1 as a placeholder. And that is the most we can do for factoring. If you want to check your work, you could distribute 3x back into the set of parentheses and make sure you get the original polynomial back. Okay, in this next example, it's a quadratic, meaning it has a squared term, and it's a trinomial. And so one way you could go about this is multiply 16 times 25. And then find two numbers that multiply to that product, but add to negative 40. But when you start seeing these huge numbers, see if it's a special case. And in this case, 16 is a perfect square, and 25 is a perfect square. And we have a middle term. And so this is a perfect square trinomial. Okay, and so square root the first, we get 4h. Square root the last, we get 5. And then you're copying the sign of the middle term, add parentheses, and then a square. And so you can verify that this is the correct answer by multiplying it out. Okay, and so 4h minus 5 times 4h minus 5 would give me 16h squared, negative 20h, negative 20h, and then positive 25. When we add our like terms, we get negative 40h. And so my final answer would be 16h squared minus 40h plus 25. Okay, so that square root trick is just a shortcut for having to work with these very large numbers and factor by grouping. This next example is also a special case. 36 is a perfect square, 1 is a perfect square, and we have a minus sign between them with no middle term. That means we're going to have the factor twice, one with a minus, one with a plus. Square root of 36c is 6c. Square root of 1 is 1. So 6c minus 1, 6c plus 1 is how this second one factors. So this first one is a perfect square trinomial, meaning three terms. This next one is a difference of two terms. And so difference of squares, meaning minus sign, has to be a minus sign. Difference of squares. Okay, and so for today's lesson, we're going to talk about how to divide a linear by a linear, And we're going to talk about how to divide quadratics by quadratics, quadratics by linears, and a lot of it just results in factoring and canceling. So looking at these first examples, we have a fraction to simplify, 24 over 60. When you simplify a factor, what you're really when you simplify a fraction, what you're really doing is factoring the numerator and factoring the denominator and looking for a common factor. So for example, 24 is the same as 6 times 4, and 60 is the same as 6 times 10. Okay, and then 6 is being multiplied on top and it's being multiplied on bottom, and so we can cancel them, leaving us with 4 over 10. And a lot of you are realizing, hey, that simplifies further to 2 over 5. But again, you are factoring that in your head, 2 times 2, 2 times 5, and the 2's also cancel. And so this fraction simplifies all the way to 2/5. And so some of you may have been able to do that in one step by recognizing that 24 is 12 times 2 and that 60 is 12 times 5. And so you could cancel that 12 and get there faster. Sometimes with these larger numbers, it takes me multiple steps. But either way, you're going to get 2/5 as your final answer because you're canceling all common factors. Okay, so the same idea here. This time our factors look a little bit different. X minus 5 is a factor. It's being multiplied on top and it's being multiplied on bottom. That's the key, is that these are factors, meaning multiplication. And so this simplifies to 15 over 12. And we can actually simplify more, recognizing that 15 is 3 times 5 and 12 is 3 times 4. And so a 3 can also cancel, leaving us with just a 5 over 4. Okay, this next one, we're not seeing anything that immediately cancels. Be very careful trying to cancel these A's. Division does not cancel with subtraction. So as soon as you have subtraction and addition happening, you can only cancel with multiplication. So that's why factoring is important. And so recognizing that this 5a minus 10, we can factor out a 5 as a GCF, which would leave us with a minus 2. And then on bottom, we still just have that a minus 2. I'm going to go ahead and put it in parentheses because we can't do anything with that. And now, just by factoring this numerator, I can see that both the numerator has an a minus 2 and the denominator has an a minus 2. And so my final answer would just be a 5, and there's nothing left on bottom, so technically a 1, which we know 5 over 1 is just the same thing as 5. So our simplified final answer would just be 5. And so that is the goal of today. When we are simplifying these rational expressions, meaning fraction bar, you're going to first factor the numerator and denominator completely, including GCFs. Okay, and so that could include GCF grouping or these special cases we did in the warm-up. Next, you are going to simplify by canceling. Okay, and so looking at this first example, let's look at the numerator first. 3m plus 6, both of those are divisible by 3, and so we can factor the numerator to 3 times m plus 2. Undistribute the 3, factor out the 3. The denominator, we have a 3 in common again, and so we can factor the denominator to 3 and then m plus n. Okay, and so the common factor I see on top and bottom is a 3. And so that leaves me with an m plus 2 and an m plus n. Be very careful. It's very tempting to cross off these m's, but you can't do that because these plus signs. This division bar only cancels with multiplication. If these were multiplication signs, we would be able to cancel the m's. But here, the m's have to stay. Okay, this next example, the numerator, we can factor out a 2, leaving k plus 4. The denominator, we can factor out a 3, leaving k plus 4. And so after the factoring step, I see that k plus 4 is a factor being multiplied on top and being multiplied on bottom. So it cancels, leaving me with 2 on top, 3 on bottom. So my final answer is 2 over 3. Okay. In this next example, we have a quadratic on top, okay? When you see this x squared, you're trying to see 2 linear factors. Same here. You see a square, you're looking for 2 linear factors. So looking at the numerator, x squared minus 9, that's a difference of squares that factors to x plus 3, x minus 3. Square root the first, you get x. Square root the last, you get 3. And then we have no middle term, so we have the plus and the minus. Okay, for the denominator, we have x squared minus 2x minus 3. A is 1, which is helpful. And so we just need 2 numbers that multiply to negative 3, but add to negative 2. And so those numbers would be 1 and negative 3. And then we can skip to writing our factors since a is 1. So x plus 1, x minus 3. Okay, and so now looking at the numerator and the denominator, x minus 3 is a common factor on top and bottom, so we can cancel it, leaving us with just an x plus 3 on top and an x plus 1 on bottom. Now be very careful. It's so tempting to cancel these x's, but you can't because of the plus sign. Okay, these aren't being multiplied on top. They're not factors, they're terms. And so do not cancel them, you have to leave them. Okay, this next example, let's focus on the numerator, which is 2h squared minus 9h plus 4. Because we have that h squared term, we know we're looking for 2 parentheses. Okay, and then for the denominator, also there's a square, and so we're going to have 2 factors that involve an h. Okay, focusing on the numerator first, 2h squared minus 9h plus 4. That 2 is not a GCF because of the 9. And so this time we have to factor using the AC method. 2 times 4 is 8. And we need 2 numbers that add to negative 9. 1 and 8 will work if they're both negative. That would multiply to positive but add to negative. Okay, and so we split the middle term, negative 9h, into negative 1h minus 8h. Copy down the first and last terms. And then we're going to factor 2 at a time. Out of the first pair, we can get h, which leaves behind a 2h minus 1. Out of the second pair, leader is negative. And then we can also divide by 4, which leaves 2h minus 1. The 2h minus 1 matches, meaning that's one of our factors, and then h minus 4 is the other. Okay, so 2h minus 1 and h minus 4. Either order. Looking at the denominator, we have negative 2h squared plus 8h. This time we're missing the constant term, so this is another GCF situation. And so we are automatically going to divide by a negative because the leader is negative. We can also divide both by 2, and they both also have an h. So we are going to divide out the negative 2h, which would leave 2 terms behind. The first term would just be h, the second term would be minus 4. So negative 2h is one of my factors, and h minus 4 is the other. Okay, and so the common factor I'm seeing here is h minus 4 and h minus 4. And so that leaves a 2h minus 1 on top and a negative 2h on bottom. Now be careful because you're seeing a 2 on top and bottom, and you're seeing an h on top and bottom. Those can't cancel because these are terms. With that minus sign, it messes us up. If that term wasn't there, we could cancel these, but because this is here, we're stuck. We're stuck with everything that's still here. Okay, for this next one, looking at the numerator, we have 2x squared plus x minus 3. We're going to need the AC method. A times c is negative 6. And then we're adding to 1. And so 2 and 3 will work if the 2 is negative. And so we're going to split the middle term into negative 2x and positive 3x. Bring down the minus 3. Bring down the 2x squared. Out of the first pair, we can divide both by a 2 and an x, which would leave us with x minus 1. Out of the second pair, we can divide by a 3, which would leave us with an x minus 1. The x minus 1 matches, and then 2x plus 3 would be our other factor. Okay, and so our numerator factors to x minus 1 and 2x plus 3. And then our denominator is going to be a little bit easier because a is 1. X squared plus x minus 2. We just need two numbers that multiply to negative 2, but add to 1, 2, and negative 1. So this would immediately factor to x plus 2 and x minus 1. You can jump to writing the factors whenever a is 1. So x plus 2, x minus 1. Okay, so after that factoring step, we look for common factors. We have an x minus 1 being multiplied on top and bottom, leaving us with just a 2x plus 3, and then an x plus 2. Remember, each of these are terms, not factors. Factors are being multiplied, terms are being added and subtracted. So these are being added, these are being added. So nothing else can cancel with this division sign. Okay, last one. Looking at the numerator, I'm actually seeing a GCF here that we can go ahead and factor out from the beginning. And so each of these terms are divisible by 3. So let's go ahead and simplify it. And so that would leave us with 2x squared plus x minus 10. And then now we can focus on this simplified form. 2 times negative 10 is negative 20. So we need two numbers that multiply to negative 20, but add to 1. That would be 5 and negative 4. So split that middle term into 5x minus 4x. Bring down your minus 10. Bring down your 2x squared. That's positive. And then we are going to factor 2 at a time. Okay, out of the first pair, we can get x, leaving 2x plus 5. Out of the second pair, we're going to get a negative for sure, and then also a 2, leaving a 2x plus 5. The 2x plus 5 matches. And then we have x minus 2. Okay, and then don't forget this original GCF of 3 that we factored out from the very beginning. Okay, and so the numerator has that 3, has the 2x plus 5, and it has the x minus 2. Okay, for the denominator, we have 2x squared plus 9x plus 10. No GCF here because 2 doesn't divide 9. So going to our AC method, 2 times 10 is 20. And then we need them to add to 9. That would be 5 and 4. So 5x plus 4x. Bring down your 10. Bring down your 2x squared. That's positive. Factor 2 at a time. Out of the first pair, we can get x, leaving 2x plus 5. Out of the second pair, we can get a 2, leaving a 2x plus 5. And so 2x plus 5 matches, and then we have the x plus 2 from the outsides. Okay, so now as we start canceling common factors, we have a 2x plus 5 and a 2x plus 5. This x minus 2 and x plus 2 look very similar, but they are different. Okay, so these factors do not cancel. And so for our final answer, we are left with the 3 and the x minus 2 on top, and then we have the x plus 2 on bottom. And so when you write your final answer, you can leave it just like that, but on a multiple choice test, they may go ahead and distribute that 3 back in to those parentheses. And so this would be an equivalent answer that is also acceptable. Both wouldn't be choices unless they were allowing for multiple correct answers. Okay, the last problems we're going to do are the application problem. And so it says the area of a rectangle is represented by this trinomial. If the base is m plus 7, find an expression that represents the height. Okay, and so we know base times height gives us the area. And so if we want to find the height, we would have to divide the area by the base. Okay, so the height is the area divided by the base. And the area is represented by m squared plus 10m plus 21. And the base is represented by the m plus 7. Okay, and so when we simplify this expression, there's kind of a shortcut when you are dividing a trinomial by a linear term. So you can actually divide the first term, m squared divided by m. You know that's going to leave you with m. And then you can look at the last term, 21 divided by 7. That would have to be 3. And so you can verify that m plus 7 times m plus 3, if you multiply those out, you would get m squared 3m, 7m, 21. Combine your like terms, you get 10m. And so that would multiply back out to m squared plus 10m plus 21, which was our original area. And so the answer to this question for the height is m plus 3. Okay, so looking at this last example, the voltage across a resistor varies directly with the current in the circuit, given by this equation, V equals IR. For a phone charger, the voltage is described by the expression x squared plus xy minus 12y squared volts, and the current is described by x plus 4y amps. Okay, find the expression to describe the resistance of the phone charger. Okay, and so we know that V equals IR, and we know that the voltage is this trinomial. And we know that the current, which is I, is this expression. We're trying to find R. So we need to divide both sides by I. So the resistance is given by the voltage divided by the current. The voltage is x squared plus xy minus 12y squared. And then the current is x plus 4y. So we're going to do that same trick as before. We are going to divide our first terms. X squared divided by x gives me x. And then negative 12y squared divided by 4y would give me negative 3 for the number. Y squared divided by y is y. Okay, and so our answer for the resistance is x minus 3y.